Welcome back. So far, we've gone through exploring why we need frameworks for building agentic applications, why LangGraph makes sense as an option for frameworks, and not only that, but also what are the three core building blocks in LangGraph. We saw that one of them was the state. Yet, however, what is state in LangGraph? Well, in this video, we'll look further in what it means to work with states in LangGraph. So first, what is state? It is a core component that all nodes interact with. It manages how data flow through the graph. The state consists of a schema and reducer functions. If we look at it more in detail, the state contains data dictionaries and supports type safety. We'll see how states are nothing more than just type dictionaries. They're very simple definitions, however, very robust and that allow for significant customization. And you might be asking, what's the difference between a schema and state? Also, because often we see those two terms mentioned and even thrown together without really being sure what's the difference between them. Well, to separate them and create some understanding. The state shows what data does exist, whereas the schema defines what data can exist. We see here how schema is more of a concept, whereas state is the actual instance. The state contains runtime data like a snapshot, whereas the schema defines the structure like a blueprint. And reflecting on how our workflows interact, looking at previous videos, we notice how the logic can get quite complicated, quite detailed and nuanced. And here we see what happens, where we have this back and forth between LLM responses, maybe some actions are executed, some APIs are called, some internal functions, and so on. And throughout this, we have the state that is being updated through messages. For example, we have the message, perform action X. Then the action is executed, and the message has perform action Y, for example, based in the result of another action, and so on. This state has all these updates until finally we have our final output and it doesn't require any further updates. Now thinking, how is this implemented? We're saying that states are very straightforward implementations. We just create classes that are inherited from typed dictionaries or from the Pydantic-based model. One very interesting option in LangGraph is that we can have multiple states if we wish to, if the logic demands it. And as we see here in this example of multiple states, we have an input state, an output state, the overall state, and so on. These states enable us to have the snapshot of the current application. And as we're also seeing in these examples, we are really flexible in what we want to define as part of the states. There is no real restriction of what we want to have inside the state. It can just be a simple string, such as user input, but we can have many more details that we can include in order to make this a much more rich object. So, to recapitulate, state is this core structure in LangGraph. States enable us to keep the current snapshot, the current state of our agentic workflow. And although they play such a major role in our application, in fact, implementing them is straightforward. It is just defining a class with type dictionary. And we see that nevertheless, we have the flexibility which attributes we want to have as part of our definition. So now that we've understood what's state and how we can use them, let's go ahead and explore the other core components of LangGraph.